Good morning or good afternoon, depending on where you're at and when you are getting a chance to watch or if you're joining us now. My name is Daryl Price, and I'm joined with Jason Gelbeck today. I want to thank you for taking the time to tune in for a short overview of what we see as a very important workflow in the industry for folks that are needing to be able to go from the plant and process design over into the structural steel and fabrication and even back, and all the while also having to work with other CAD solutions to bring in components. The point is, there is no one single solution that covers this gamut, and today Jason's going to give you a good walkthrough of the types of tools that cover the specific parts of that workflow and the value that they add to the process. So with that, Jason, I'm going to go ahead and turn it over to you and let you take it from here.
Thank you, Daryl. Hello, everyone. Yes, I'm excited to present to you the pipe to steel working with AutoCAD's Plant 3D and Advanced Steel products. I'll start, let's take a look at our topics that we'll cover today. We'll start with the workflow with the AutoCAD Plant 3D and the Advanced Steel. Then we'll take a look at exchanging information between them. Also, I'll go ahead and look at how to bring in an inventor model into our Plant 3D environment, as well as the interoperability with Advanced Steel and Revit. Let's begin with some work in the AutoCAD Plant 3D product. To start, AutoCAD Plant 3D has P&ID built in, which helps us schematically develop our design before working out the detail in our 3D model. Since Plant 3D is built on the AutoCAD core, creating and editing the P&ID elements, as well as the 3D piping, as we'll discover next, is very simple and intuitive. When ready, we can use the data created in the P&ID drawings to help us develop our 3D model. The P&ID line list command will let us review the pipelines and valves created in all the P&ID drawings, as well as allow us to place them directly into our 3D model with all the associated data that has already been applied, such as line number, tag number, spec, plus all the other data. Additionally, we can create piping, new piping supports, equipment, and other elements as needed for the design, even without referring to the P&ID data. But as before, using the AutoCAD edit commands can make light work of placing these new elements. Here we can copy equipment and piping and make connections back to the existing pipelines. Now, at any stage of the process, structural elements can be added using the array of tools at our disposal under the structural ribbon within AutoCAD Plant 3D. General structural objects such as columns, beams, stairs, railings, and even grates can be added in with the options needed to choose things like standard, shape, size, as well as the orientation and alignment. Placement of these items can be made easier by using Plant 3D's structural grid. Values for length, width, and height can be set, giving us easy snap locations to place in our components. Now that we have our basic structural layout, we would like to export this to our Advanced Steel product. Under the same structural ribbon, choose the Advanced Steel XML export, select the file name and location, and then choose the structural elements that you would like to export. Within the Advanced Steel, we can now import that file. The Plant 3D structural elements are converted into Advanced Steel structural elements. Even our grid system comes over to assist us in continuing our layout work. In Advanced Steel, we can add additional items like columns, beams, stairs, railings, and plates again, but we can also create relational groups such as portals, trusses, joists, and many other items, as well as the connections. After creating our structure, we'll need a method to connect them together. To assist us, there is a vast list of common connection types available within our connection vault. Of course, we can create our own custom connections as well. Find a category and the type needed, select the elements involved, and Advanced Steel will build the connection, shape the elements, and add the bolts, plates, and welds as defined. Libraries of standard configurations can be saved and reused. Before our detail sheets can be created, we'll need to apply a naming process in Advanced Steel. This will name every part for labeling in our detail sheets. But once this is complete, generating details is a breeze. Just select the option needed for both single parts and assemblies and let the program do the work. Now that that's finished, we can review our drawing files in the Document Manager. Here, we can print, add revision notes, and even open the sheets to make adjustments as necessary, as well as edit and add additional annotation. More details, plans, elevation views can be easily added or copied from other sheets. If we need this new Advanced Steel model back in our Plant 3D model, we'll then just use the external reference commands to bring in our updated Advanced Steel model. We just need to remove the Plant 3D structural external reference and attach the newly modified Advanced Steel drawing. If any equipment is needed, has been created in Autodesk's Inventor, just use the BIM content environment built in. Make sure to take advantage of the shrink wrap substitute to reduce the model complexity and help model sizes in our Plant 3D program. We can create pipe connectors for use in our Plant 3D model, although it isn't necessary because we can also add these connectors once in the Plant 3D program. Start the Export Building Components command and choose an ADSK file. When complete, a report is created for your review. Now back in our Plant 3D, we'll use the Convert Inventor Equipment command to bring in that Inventor assembly and define what type of equipment that it is. Since we've chosen to add the connectors within the Plant 3D, we'll use the nozzle connection point to our equipment with this Add Nozzle Grip. After defining its location and orientation, then we'll define its type, size, pressure class, and other information for the nozzle connection. We can now use this connection to continue on with our piping layout, all with simple grip editing and then routing the new pipe. With all the elements brought together, our Advanced Steel structures, our Inventor equipment, along with our Plant 3D elements, we're ready to create our orthographic views with all the detail applied. All that's left is to create some additional views, a bill of materials, and any additional annotation as needed. Isometric views are just as easily created with bill of materials, annotations, and dimensions already applied. Additional collaboration can be performed with Advanced Steel and Revit. The Advanced Steel model can be exported out to many different file types, but the same SMLX file works best for the interoperability with Revit. Use the Advanced Steel extension add-in for Revit, free from the Autodesk App Store, to import your Advanced Steel SMLX file. With this extension added to Revit, we'll also get many of the common connections from the Advanced Steel. We can add these families to our project and make the connections in our Revit environment. Select the connection type needed, pick each structural element involved, and the connection is added the same as it is in the Advanced Steel product. We can even make the same adjustments to the connection parameters that we would in the advanced steel. Within both Revit and Advanced Steel, we can run a synchronization tool to refresh our model from the updated SMLX file. Here, we've refreshed our Advanced Steel model with the additions we've made within the Revit environment. That's it. I'd like to thank everyone for joining us in this presentation of Pipe to Steel. Please let us know if you have any questions, and look for the recording of this coming soon to our website. Thank you again, and have a great day.